Hello, I'm going to be showing you guys a tutorial on how to do the Waypoint system that Batman Arkham games had for the Grapnel hook. Not the actual Grapnel hook where it pulls you in, but the actual system where it places a marker for where you're going to grapnel to. And also, I wanted to let you guys know that this is a rough version. This is not in a perfect version, but it definitely does work. As you can see, it's getting to the edge of it, and right now it's getting the closest edge that it can hit. That's closest to me. If I can also switch to get the farthest. Oh wait, no, this is getting the closest, so if I get the farthest, that's actually hitting the back. Yeah, my bad. I was toggled on the wrong one. So right now it's using the farthest edge from me. See? And I switch and it goes to the closest. See? Alright. So how do I set this up? Well, let me delete the example version. And right now we just have a character that just runs around. And prior to showing this off and getting this working, it only works with static meshes that have simple collision, not complex. And I'll show you how to fix that. So you select the static mesh that has complex collision, and you go to the static mesh. Let me show you. Simple collision, complex, etc. So there you go. You go down in the details to collision complexity. Change that to use simple collision instead of use complex collision as simple. Use this one. And then you go to collision, you remove the current collision, and if you don't have this tab open, you can just click on auto complex collision. And then for the stairs, at least, you had to max this out for both of them and hit apply to get the best results. Every other one, you can just use the maximum and the accuracy and it's fine. But you hit apply, wait for it to do its thing, save, and you're done. And then you're not going to be having errors. Yeah, I guess it's something with Unreal's sort of component part of it. Yeah, but yeah, it works. It doesn't really change anything at all, really. It's just a collision of it. So let's open up the, oh wait, what's this? The bounds, right. So I made a structure called bounds, and the way you can do that is right click, blueprints, structure. All right, and then I just named it bounds. You open it up and you're going to have these values. I'm going to show you how to get essentially the components bounds of the origin, the extent, the min, the max, the size, and I'll explain what that is momentarily. So yeah, these are the values. You just add a new variable. They're all vectors, and that's it. Doesn't really matter what the default value is because you're going to be setting it in code anyway. All right, maybe I should keep that open and explain this. So let's start with the first one, origin. Origin is pretty much the origin point of the collision, or the bounds of it. So the bounds of this object, of this cube, is that point right there. Now the extent is the distance from that point to the edge of the, any of the faces or, edge or whatever. It's pretty much a distance between those two. Then the min is, the minimum and maximum are pretty much opposites of each other that correlate. So that's a fancy way of saying minimum is if you were saying minimum in the X, it would be this side, the left or back face, which would be back face, and then the right face would be the maximum. So whichever way the arrows are pointing, that's the maximum. The opposite is minimum. So the minimum point of this cube would be this corner right here, and the maximum would be this cube or this corner right here. And how I do that is go forward, and then since this is pointing to the right, and that's pointing up, so up, and then there you go. And then you just do the opposite with that one, with that corner. And then the size is extent multiplied by 2. And that's it. That's what the size is, and the size is pretty much just how big it is in the length. So all I did so far was I deleted the stuff for the VR, and if we go in project settings, reset VR is the R key, and we're going to be using that for debugging. I haven't really changed any other values. This is the default third person example template. So right now I'm going to create the debug variable. So toggle debug, and then we're going to set it to true on this one, flip flop, and then this, oops, that, there we go. So debug is set, compile, save. All right, so the actual part of it where it's getting the the edge. So I'm doing this in tick, and the way I'm doing it is a multi-sphere trace. You can use a cone collision if you prefer, and the way you would do that, and that's probably what they did for the Batman Arkham games, a good example of it is if you go to the Learn tab and scroll down, you go to the Blueprints project and download that. They have a good example of it, of using cone collision, and then you can kind of modify it for this, for what I'm doing here. Alright, so let me get my notes up so that way I don't miss anything. Always gotta have my notes. And we're gonna need a lot of space. So first, what we're gonna do is we're gonna start from the camera position, and for our starting trace, so get world location, and we're gonna be shooting it. We're gonna be starting from the world location and starting from where the character is, because if we have it start at the camera's location, when we walk into, say, the wall, it's going to be hitting the wall, and then we're going to be hitting whatever the camera's colliding to instead of what's in front of us, and this fixes that. So the way you would do that is forward vector, simple trace stuff, multiply by float, and then add the two, and the value we're multiplying by is the camera boom, or the spring arm, get target arm length. So that way we go the distance, we're pretty much going the distance from, we're getting the distance between here and here. So it's starting at the character instead of over here, but it's oriented by the camera. Alright, so we promote that to a variable, start trace, and then we save that value in every tick. And then we just repeat that process, but for the end trace. And trace. And this one we can actually change. So promote to variable trace length, and then we're going to change the length to, let me compile, trace length to, let's say, 5,000. So we crank it up a lot. And there we go. We have that. Alright, so now we're going to do the closest edge first. So we're going to do multi-sphere trace by channel. And since we're searching for things that block with visibility, I turned the visibility channel to ignore for the floor just by going to collision, set it to custom, and then I just change that to ignore it so it doesn't hit that, because hitting the ground would not be good, obviously, for what you're trying to do, which is, for gameplay purposes. So we're gonna set our start, end location, promote that to a variable, trace radius, compile so we can edit it, and let's try 50. An easier version. Alright, trace visibility, yep. Alright, we're gonna make an array to ignore ourselves, so get owner, and that's this actor. And then what we're gonna do for debugging is select, and then we're gonna toggle debug. If it's false, don't debug. If it's true, do it for 1 frame, because we're gonna be doing this in tick. So we drag that over. And yeah, that's pretty much it for the trace part of it, or that part. Then we're going to promote this to a variable called outHits, And the reason why is so when we do another trace for the, farthest actor, or the farthest edge, then we're gonna just be using that variable instead of like dragging it out to do a for loop, or for each loop. So for each loop, drag that over there. Let's drag this over here so we get space. Compile, save, and now we're going to start on actually doing the math for getting the closest actor. So currently what we're doing is we're tracing from the character forward to here, and it's going to hit this, this, and this. And currently we're setting it up so it hits this one first. And the way we would do that is first we're going to break the hit result, and we're using the primitive component. So we're going to do target component, and we're going to move that over there, and we're going to check if it is valid. Because if it's not valid, when we do a comparison for the first one, it's going to give us an error because it's going to go, huh, I can't compare against anything because you don't have anything to compare against. And we're going to make a buffer to fix that, or an edge case. So we're going to put in a branch, and if the comparison shows that we have a closer actor, then we set it to that one. And we're also going to be saving the impact point, which is hit point. So that way we save that. There we go. Now, what we're going to do here is, if it's valid, we're going to get the distance between ourself and that actor. So we're going to get owner, get distance to, and then we'll connect that and promote this to a variable. So current tart get distance. And then we only do that if it's valid. If it's not valid, then we just do a general comparison that's going to handle it. Yeah. And I'll show you how to do that. So since we're checking against the actor's distance, we're going to use this hit actor. We're going to use the same thing that we just did there, except with that. And we're going to check if it's less than a value. Plug that in there. And what we're going to be checking if it's less than is this. So if we have a value, then we use this. If not, then we're going to be checking against the end location, since it should be close enough. So if I trace forward, it's going to hit all three of these. It's going to hit this one and say, yeah, it's closer than the one over here, which is the end of the trace. This is also closer, this is also closer, but this one is the first one that we hit. So that's going to be the closest. And one thing that we can do is check if this is valid, all right, and then we're going to select a float. And the reason why we're doing that is so that way it handles that first one, the edge case. And we're going to use the trace length if the component is not valid. If it is valid, then we use this to compare against. And that's all the math that we need to do for getting the closest actor. So next what we do is we're going to copy this over here. We're going to drag that into completed, nil space. All right, so now that we have our component, how do we get the bounds of it that we were doing before? So we're going to create a variable called bounds, which was that struct that we made earlier. Hopefully you did. Otherwise, you can just use one vector, but this is just for you to learn it in general. So we're going to drag that out of this, or you can use a vector, make bounds, or vector. Alright, so now we have origin, extent, min, max, size. As I told you earlier, we can just do simple calculations using the target components bounds. So we get component bounds, but it only gives us origin and box extent, so we can drag at least those two in without having to do any math. The other ones we do have to do math, And the way we do that is, for minimum, we subtract the two. And it's a specific order. And then max is the opposite, so add them. And then for size, all we have to do is grab the box extent, multiply that by an integer, because I don't want it to be a floating point where it gives me a problem, and that's it. And you multiply it by 2. That's your integer. So now we have the bounds of it. So now we just have to figure out how to get that edge on the bounds that's closest to him. So the way you do that is you get the hit point, and then you're going to be adding in a vector, and then you split that, so we only are adding in the z. Alright, so we get the bounds, break bounds, and we're only going to be getting the max since we want the top, which is going to be the top edge. So we're going to split, and then we're going to max z, and that's it. And we can collapse that so we get a little bit more space. There we go. And then, now how do we do that with the actual bounds of it? So we're going to be using our component again. We're going to get closest point on collision. And I'll explain what this does in a moment. But we're going to save that end value out as the end point. And there we go. Now we have our actual edge. Alright? So what this does, what we're doing here right now is when we shoot a trace, we're shooting it, say, on this face. I shoot it on this face, it gets it to this point, and then we add the actual z up, the distance between here and z, we add it, but it's going to make it fly up here. But at least it's going to be in the same kind of edge, you know? But if we want it to be actually like on the actual edge, this locks it to that, because it's going to get the closest, you know, location compared to that, which is, you know, so it's going to be up here, and then the closest point is going to be just pretty much down, straight down from there. That pretty much locks it to our edge. And then we're going to comment this as our closest edge point. Alright, so how do we actually show that? Well, we can just do draw debug sphere, which is what I like to use because they're easy to see. We're going to change the thickness to 5, radius to 25, and we're going to use the endpoint as its center, which is where it's going to be. And then we compile, save, play it, and then, oops, hang on. But yeah, as you can see, it's stuck there, and the way you can fix that is just setting that back to null. Because every frame it's going to be doing this. So once it finishes finding all of it and drawing it and doing all the things that we need it to, we set it to null at the end. So that way we can do it again with another thing. And as you can see, it's getting the closest one. And if I hit R, which is our debug, we can see it's hitting something. See? But if I don't hit anything, yeah. So it's always going to be turning it to null. Actually, yeah, you should probably also do this. If it's not valid, set it to null anyway, just in case, you know? That's always a good practice. So, now that we have that, let me actually change this to red. How do we get the closest value? Well, so, it's pretty simple. We only have to do one other thing at the end of it, but it's pretty simple comparatively. So, add a branch up here, and we're going to be doing a different type of multi-sphere trace. And I'm going to drag this stuff up, connect that to true, and we're going to promote this to a variable and call that closest edge. Oh wait, no, let's do get closest edge. So if we want to get the closest edge, then we use this trace. If we don't want the closest edge, then we use this trace, which will be the farthest. Oops. Farthest. closest. So we still use the same trace radius and same nonsense with this stuff. Let me drag that over. All right, you. But now we do a different start and end point, and all you have to do is just flip it. Ta-da! There we go. And it's the same thing with this. And then we just plug that in, and then we hit play. But wait, it works. There you go. Oh wait, no, we didn't. It's still true. So how do we fix that? Set that to false, and then it's going to be, hang on 1 second, my phone. Alright, so now as you can see it's doing that, but it's going towards that edge, to the opposite edge. And how do we fix that? Well, the way we fix that is we get this again, we do another branch, and what we're going to be doing is we're going to line trace to where it is, and we're pretty much just going to be doing a line trace to get the closest point comparatively, you know. So this one's pretty simple as well. Line trace by channel, and the start and end locations, you use the start location, and this time we're going to actually trace to the end point, or to the hit point that we have, you know. So, and we also have to make an array where it ignores itself. So get owner, and then there we go. And if you want, you can also do the same thing that we did earlier with this, where it was, you know, debug, type, etc. And now we just break hit result, and this time we just add the impact point in the vector, and we just do the same thing, except this time we're not using the actual hit point, we're using the impact point here. So copy that. We can actually just do that instead. Yeah, it's pretty much the same thing, you know. Let's drag this over and set our endpoint to this. All right. So what this does is it's shooting a line straight to where our endpoint is, where we hit, and then from that impact point we're adding, it's pretty much going to shoot it again. So it's like, all right, I'm going towards you now from my direction instead of the opposite, and it's going to be shooting that, and then we just use that impact point instead of the one that's on the other side, because that's where the impact point is being set when we go from the opposite direction. Because what we're doing is, since we flipped the trace points, or the end and start, it's shooting from this direction. So it's pretty much getting that direction side. But when we shoot a line over there to where it is, it's going to hit it, and it's going to say, alright, I guess this is the direction you want, which is this one. And that's how you pretty much set it. So let's play, and there you go. See? Hit debug and you can do that, and we can actually flip it as well using the same thing, except this time we use get closest edge, same exact way too, true and false. And then I hit R, it's getting the closest one. I hit R again, it's getting the farthest. See? So yeah, that's how you do that. That's how you get the Batman Arkham Grapnel hook waypoint system set up. And you can always modify and add more and all that nonsense. Yeah. So yeah, thank you for watching. Have a nice day.